All right, here we go. It says graph the graph of a periodic function y equals f of x is shown below. And so it's same graph we were dealing with in the last video. And we're going to be translating it quite a few times here, translating or dilating. So first off, just to kind of to be explicit about a few points, that translation, another word for that would be to shift it, to slide it, just to move it up or down, or up, down, or left or right. And so it's going to happen when we are adding or subtracting. So it comes from adding or subtracting. On the other hand, we also have dilations. And kind of the way to think of that is going to be to stretch it or to shrink it. And that's going to happen when we either multiply or divide. Multiply or divide. All right, so let's go ahead and talk about this. And actually, one more kind of small point, but important as well. Our input right here, the stuff inside that parentheses, is called the argument. And if you think of argument really in the best sense of the word, not with the negative connotations, argument. If somebody asks you for your input on something, it's like, hey, what should we have for dinner tonight? In the best connotation of the word, they're asking for your input for your argument. Like, well, we should have pizza because the other day yesterday we had, I don't know, salad. And so again, the best sense of the word argument is really what's your input. And so just keep that in mind. That if you're hearing the word argument in terms of math, it's saying what is the input that we're going to be plugging into the function. So that all being said, let's go ahead and start graphing some of these. So sketch the graphs of y equals f of x plus 2. So that is going to be a translation because it's adding or subtracting. We're going to be either moving it left or right. And if you think of it as in terms of y equals f of x minus h plus v or plus k, this is going to be an h value of -2. So we're going to be moving the whole graph to the left. So every point on here moves to the left. That point goes 1, 2. Now it's there. Here we are, 1, 2. Here, 1, 2. 1, 2. And so on, so forth. And we have our new graph. Everything's been shifted to the left. To the left. There's our new graph. All right. Next we have f of x plus 2, and so that's going to be a v value. So v equals 2 on this one, meaning the whole graph is going to be raised 2. So every point has been moved up 2 spaces, 2 units, so on, so forth. And there's our new graph. All right, our next one here, D, it says sketch the graphs of 2 times f of x. So this time we've got a dilation, and we're multiplying all the y values by 2. And so our back in terms of our notes back on page 1, remember that was our c value on the outside of the function, meant that we were going to dilate it vertically. So here we go. Let's go ahead and do that. All the points get multiplied by 2. That means 0 is still always 0. That one's not going to move at all. We can put all those zeros on our graph already. But the rest of them, now we had 1, that times 2 is 2. And where I had 1, that's times 2 is 2. I had -1, it's -2. So on, so forth. Everything's getting multiplied by 2. So our amplitude has just doubled because our maximum, which was at 1, now is at 2. Our minimum, which was at -1, is now at -2. So 2 minus -2 is 4, and 4 divided by 2, our new amplitude equals 2, where it was 1 previously. All right. And then I would pause the video, try this next one where we have y equals f of 2 times x. We're multiplying the input by 2 before we even graph it. So again, would pause the video and try that. Here is what you hopefully ended up with. That the x values are getting, it's all being repeated more frequently. So right now our period, if we remember talking about our period, the fundamental period is 5 units. Now it's going to be 2.5 units that it's all getting repeated as. So everything is happening twice as soon. And so where it was at 3, now it's at 1/2. Where it was at 4, now it's at 2. And where it was at 2, now it's at 1. Where it was at 1, it's now at 1/2. Sorry, that point there is incorrect. Where it was at 4, now it's at 2. And so I'm going to sketch it here. Everything's happening twice as quickly. Twice as quickly. So if it was at, what would that next value be? The next one would be 9, so it's going to happen now at 4.5. Looking something like that. And I'm sketching it a bit here just to kind of emphasize the point, but it's all happening twice as quickly. So those first ones should be accurate, and after here I got a little messy, but hope that helps. We'll continue on the next 4 graphs in the next video.